In this video, we're going to talk about numerical measures of spread for one quantitative variable, and we're also going to demonstrate how to use StatCrunch to get all of these values that we've talked about. So for measures of spread, the first one you've probably heard of before, and that's just the range of the data set. The range is just the maximum value minus the minimum value. What may be new is this interquartile range. The interquartile range uses those quartiles that we talked about in the previous video. So here we're taking that 75th percentile minus the 25th percentile. So what we're actually getting here is the middle 50% of our data. A last measure of spread that you may have heard of before, possibly even had to have calculated before, is called the standard deviation. The standard deviation is thought to be as the typical distance an observation is from the mean. And so we're looking at this distance from the mean. So we are not going to be calculating this value by hand. We will be using StatCrunch, but I do want us to feel comfortable with the idea of what it's doing. However, first, let's talk about the symbols that we're going to use for standard deviation. The lowercase sigma we already saw in our normals notes. This technically represents the population standard deviation. But now that we know we will not always have the entire population, we introduce a new symbol of S, which just represents the sample standard deviation. Now let's look at a few data sets to understand why this may be a useful measure to look at. So we are going to look at 3 different data sets. Data set 1 consists of 5 values, where every single value is just 20. Data set 2 also consists of 5 values. But here they are 15, 17, 20, 23, and 26. And our final data set 3, consists of 5 values, but they are 1, 1, 20, 39, and 39. So first, for each of these data sets, we could calculate the mean. Here, since there's only 5 numbers, it'd be quite easy to calculate it by hand of just adding up the 5 numbers and dividing by 5. When I do that, for each of the data sets here, we will actually get the same mean. Every single one has a mean of 20. However, if we were to just look at the mean, it doesn't really let us know that these data sets are very different, but they are quite different. So standard deviation is going to help us have an idea of how different these values actually are from each other. So if we're looking at the typical distance an observation falls from the mean, and I look at data set 1, well, all of those values are exactly the same as the mean. And so it probably will not be surprising to find out that our standard deviation there will turn out to be 0, because they have 0 distance from the mean. Now for data set 2, these values are different also from the mean, but they're not very different. They only go from 14 to 26. So by calculating the standard deviation, which again we will be using StatCrunch for, we're going to get about 4.743 for that standard deviation. So typically it's 20 plus or minus this 4.743. So, or we kind of feel like the typical observation's a little bit more than 4 away from 20. Notice we're not saying every value. It's the typical value. Finally, for data set 3, if I were to calculate this one, which is now very different compared to the other two because the values have a much wider spread, the standard deviation here turns out to be 19. So our typical distance, those observations fall from the mean, is 19. So again, that's just to introduce the idea. So we're not going to do this calculation. Let's actually look at this for a data set. So we are going to be looking at the earnings of PGA golfers in 2013. So this data set is provided for you as well. So bringing up the data set here in StatCrunch, this is what it looks like. So we recorded someone's age, how many wins of how many tournaments they won, as well as how many earnings they had in dollars. So if I want to get all of those values, my mean, my median, that 5-number summary, the standard deviation, where I'm going to go is to Stat, Summary Statistics, by columns. I went by columns because that's how my data is organized. I'm going to click the variable I want. Here we're going to focus on earnings. And then I'm going to go down here and click the ones I want. And I'm going to control click them. So I want the N, the mean, the standard deviation. Notice I'm skipping over the ones we haven't covered. The median, the min, the max. And there's my Q1 and my Q3. So then I'll just hit compute. And this will be matching what we saw here in our data set. So now we're just going to use these values to understand what that standard deviation is really measuring. So standard deviation again measures that typical distance we fall from the mean. So I'm going to start at the mean. Well, the mean was 1.26-ish million here. And my typical distance from that mean is this 1.24 million. And so I'm just going to go out that distance in both directions. So when I do that math, I'm just going to subtract off to the left, and I get $14,129. When I add it on the right-hand side, I get $2,512,307. So then what I could really say here then is that our typical PGA player earned between our $14,129 and our $2.512 million in 2013. So again, we're not saying all. This is just where the typical player falls. So here's those directions for StatCrunch for you. So that way, if you ever need to do this in StatCrunch, you have that idea. Sometimes I will round the values a little bit differently. So here, notice I rounded these to whole numbers compared to what we actually got in StatCrunch, because they actually gave some decimals, but I really don't think millionaires really care about the cents attached to what they won there as well. Also, so just kind of as a reminder of some new symbols that we've seen. So Y bar, again, represents our sample mean. S is our sample standard deviation. So although we've talked about mean and standard deviation before, we have some new symbols to represent when we have sample values, which are our statistics, those numbers that we calculate from a sample instead. And N is going to be our sample size. These are going to be more and more important as we go throughout these videos. So do make sure you feel comfortable with these new symbols. That way you can use the formula sheet appropriately.